Hi everybody. So some of you had some questions about problems out of 3.2 and 3.4. So I thought what I would do is just go through a few of these today and hopefully be able to get you back on the right track. So I'm going to start off with number 9 out of section 3.2, and this is a sum of two integers problem. Okay, so it tells us that the sum of two integers is 87, and we are to find the numbers for that. So usually what I like to do is just represent those in a very basic way. So I'm going to say a plus b equals 87. Okay. Now, if they're consecutive integers, meaning they're in a row, we know that we could say the first integer we can just call a. Okay. Now, if they're in a row, that means, or in order, that means that the next integer is going to be one more than the previous one. So how can I represent that? Well, think about the number 2. Okay, let's just say 2. What do you have to add to 2 to get 3? And the answer is 1. So here I can represent that second integer by just saying a plus 1 is equal to 87. And then it just becomes an algebra problem that we need to solve. You notice here I put parentheses here around the a plus 1. That's the same thing as b here. Okay, so I like to separate it out. Visually, for me, it makes more sense to do it that way. But let's just go ahead and continue solving here. So if I add together my like terms, I get 2a plus 1 is equal to 87. Subtract 1 from each side, and I now have 2a is equal to 86. Divide both sides by 2, and I get a is equal to 43. Well, if a is 43, that means that our second integer, a plus 1, then has to be 44. So our answer is 43 and 44. Okay. Let's go ahead and try another one. Okay, so now let's look at something like number 11. Okay, with number 11, it tells you that two consecutive odd integers equal 96. So I'm going to start this one off the same way that I started off the last one. But this time, I know that I am looking for odd integers. So let's just say a. Well, what do you have to add in order to get the next odd integer? So think back to odd integers. 1, 3, 5, 7, 9, 11. All of those are in increments of 2. So this method also works if you're asked to find it for consecutive even integers. It's the same process. So here, my second integer is going to look like a plus 2. Okay, and then just like the previous problem, we can go ahead and solve this. So I have 2a plus 2 equals 96. Subtract 2 from either side. You get 2a is equal to 94. Divide both sides by 2, and you're going to get a is equal to 47. Just like the last one, I would say, okay, well, 2 more then would be 49. So your two numbers are 47 and 49. Okay. So once you understand that basic process, this all pretty much works the same. Okay, so now go ahead and look at number 15. Okay, 15, you have to be able to translate. Okay, so one number is 3 more than twice a second number. Their sum is 27. Find the numbers. Okay, so we know that we are dealing with two integers here and that they sum to be 27. So I'm just going to start with that. You'll find oftentimes that it's almost easier to translate the last sentence first and then go back and translate rest of the problem. Okay, now let's go back and reread it again. one number. So pick either A or B to be that number. I'm just going to choose A. Okay. So one number, A, is means equals 3 more, so 3 more than twice a second number. Than twice a second number. Okay. Now, the trick when you get it to this point is realizing that, I have this solved here for A. So I could just go ahead and substitute this part right here back in up here for A. And then you have everything in terms of one variable, which is what we want. So let's go back now and substitute back in. So I'm going to say 3, oops, get my color right here. I'm going to say 3 plus 2b, okay, plus b equals 27. So this part right here, that was our A, and then our B. Now combine your like terms together, so you have 3 plus 3b is equal to 27. Subtract 3 from each side. So now you have 3b is equal to 24. Go ahead and divide both sides by 3, and you're going to get b is equal to 8. Well, if b equals 8, I know that a then would equal 3 plus 2 times 8. Oops, there we go. So I know that that's going to equal 19. So my two numbers are b equals 8 and a equals 19. All right. So I think that wraps up most of these problems. Let's just take a look at one more. I wanted us to look at 17 also. 17 is a little different too, okay? It says, you know, if you start with the last sentence first here, and it says, find the two numbers. So we know that we are finding or dealing with two numbers here, and we know that the difference between those two numbers is 17, if you read through the problem. So I know that a minus b is equal to 17. Okay. We also know from reading this problem, it says that the larger of the two numbers, well, a here has to be larger because our answer is positive. So a is 8 less than twice the smaller. Remember, is means equals. When it says 8 less than, kind of think about putting that over here, okay? And then twice the smaller, so 2b minus 8. So 8 less than twice the smaller number. Again, just like the last problem now, we're going to go ahead and substitute in back for a to solve. So if you do that, you're going to take this piece right here and substitute that back in for a. So you now would have 2b minus 8 minus b is equal to 17. Okay. 2b minus b is a 1b, or just b. Go ahead and add that to each side, and you're going to get b is equal to 25. Okay. Well, thinking about our original equation then, if you have a minus 25 equals 17, add that to each side, and you'll get a is equal to 42. Okay? So a lot of these problems are not hard once you get used to the fact that you need to translate them, and translating them properly is the hardest part about these. So do be sure to take your time. And I hope that that helps with problems out of section 3.2 for you.